This is a short video to introduce the Frese Alpha flow limiting valve. This is possibly our simplest pressure independent valve, and is simply a Y-shaped cavity together with a pair of PT plugs in order that the pressure drop across the valve or the cartridge that goes inside the valve can be calculated. Here we can remove the cap and install our flow cartridge, and it is this device that regulates the flow through the valve. In fact, the Alpha flow cartridge is made of two parts. Firstly, there is a fixed area inlet, what we can call a KV, and then behind that is a varying orifice outlet, which is basically a differential pressure controller. The way the product works is that this is installed into the flow path in this chamber here, and as flow comes down the pipe towards the cartridge, the pressure acts upon the front area of this orifice, and after a certain amount of pressure, typically 10, 12, 13 kPa, this will start to push close against a spring. Once water flows inside the cartridge, then there is also pressure, but it has lost a little pressure, so it's naturally a little lower, but that pressure is pushing back against the backside of the same orifice. But internally, this spring also helps by adding a force, so the pressure or the force coming from the internal pressure added to the spring force becomes equal and opposite to the force pushing the cartridge down. So at any point, whether it be just 10, 12 kPa all the way up to 600 kPa, the Alpha cartridge will find an equilibrium point, but always there is a constant pressure loss across a constant area, and therefore this is the constant flow when the valve is under control. This has three key benefits. One, if we have a piece of debris that comes into the valve, it could get stuck through the narrow flow path on the exit, but generally that will increase the internal pressure and open the cartridge, and the dirt can go on its way. Even if it doesn't go on its way, the cartridge will find just a new equilibrium point, and the flow has not been affected, or the pressure loss across the orifice plate has not been affected. Secondly, there is a diaphragm. Actually, can be seen better in this particular larger cartridge we have just here, where this rolling diaphragm prevents any internal leakage through this annulus area of the cartridge. And that means that irrespective of how small the cartridges become, there is never any flow anywhere other than where we want it to go. So they remain as accurate at small flows as they do at high flows. And I guess a beneficial side effect of the rubber cartridge is that you shake it, it is silent. And this has been a big step forward on some of the earlier generations of flow cartridge. And that summarises our Alpha flow technology. Thanks very much.